Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is the Pure Mathematics 1 for October-November 2021, and the code is 9709/13. So let's move on to question number 1. Question number 1. The graph of y equals to fx is transformed to the graph of y equals to 3 minus fx. Describe fully in correct order the two transformations that have been combined. So first of all, y equals to 3 minus fx, I can write this as y equals to minus fx plus 3. Okay, so from here, the first transformation is the y equals to minus fx, and then the second transformation is the plus 3. Okay, so from here, the minus fx is basically referring to the reflection in the x-axis. Okay, and then for the plus 3, that is translation. So I will write followed by translation. So since the plus 3 over here is the effect on the y value, okay, therefore the translation is going to be 0, 3. So there's no effect on the x values. So this is the transformations. Okay, so done for the question number 1. So for question number 2a, find the first three terms in ascending powers of x in the expansion of 1 plus ax to the power 6. So 1 plus ax to the power 6, we use the formula a plus b to the power of n. Okay, then it will be a n plus nc1 a to the power of n minus 1 b degree 1 until b degree n. So from here, my a is 1. Okay, and then my b is ax. Alright, so by using the formula here, the binomial expansion formula, I will be getting 1 power 6 plus 6c1, 1 degree 5, ax degree 1. Then we need to expand until first three terms. So this is our second term, and the third term is going to be 6c2, 1 degree 4, ax degree 2. Okay, these are the first three terms, and now we need to simplify them. So the first term will be 1, and then 6c1 times 1 degree 5 will be 6. Then ax degree 1, it will be ax, and the third term will be 6c2, that is 15. So plus 15, 1 degree 4 is still 1. Square of ax will be a square x squared. So these are the first three terms in the expansion. Now b, given that the coefficient for x squared in this expansion is minus 3, find the possible values of a. Right, so 1 minus 3x multiplied with 1 plus ax degree 6. Just now we have solved for the expansion of 1 plus ax degree 6. So I will rewrite that three terms from the previous part. So then you will be getting 1 plus 6ax plus 15 a square x squared. Okay, and now we need to get the coefficient of x squared. So it means that this one, okay, I will multiply to the x squared, and then for the negative 3x, I will multiply to 6ax. So I will be getting 15 a square x squared. Then this minus 3x, when you multiply with 6ax, is basically minus 18 ax squared. And also we have other terms, so we just ignore it. Now it's mentioned that the coefficient for x squared is minus 3. So that means I will write minus 3 equals to, the coefficients will be 15a squared minus 18a, okay, on the right side. So here I will get 15a squared minus 18a. Then now this is a quadratic equation. Then I will just divide the whole equation by 3 first and rearrange to get a quadratic equation. So here minus 1 equals to 5a squared minus 6a. Therefore, 5a squared minus 6a plus 1 equals to 0. And then now we need to get the possible values of a. Therefore, now we have to factorize the quadratic equation. And then from here, you will be getting a minus 1 multiplied with 5a minus 1. That equals to 0. Hence, a minus 1 equals to 0, or 5a minus 1 equals to 0 means that you either get a equals to 1 or a equals to 1 over 5. So these are the two a values for parts B. Okay, for question 3a, express 5y squared minus 30y plus 50 in the form of 5 bracket square of y plus a plus b, where a and b are constants. So to get this form, we need to apply completing the square method. So now, first of all, right, we need to factorize the 5. Then you'll be getting y squared minus 6y plus 10. Then after that, according to the completing the square method, you need to rewrite the first two terms and then plus square bracket square minus bracket squared and then plus another 10 outside. Okay, plus 10 before the close bracket. So the term inside the brackets will be the coefficient of y divided by 2. So that means it's minus 6 divided by 2. So I will just show you step by step. Okay, after that, next step is going to be combine the first and third term. Okay, so the first term is y squared. So we just put a bracket, write y, and then square outside. Now for the third term, it is minus 6 over 2, which is minus 3. Then now, negative 3 squared plus 10. So here I will get 5 times y minus 3 squared. So the total of these two terms, it will be minus 9 plus 10, which is 1. Okay, so here plus 1. Then now, to get the given form, the 5 must times into the square bracket. So it will be 5 bracket y minus 3 squared. So 5 times 1 is plus 5. So that's the solution of this question 3a. Now b, the function f is defined by fx equals to x degree 5 minus 10x cubed plus 50x. For x is real number, determine whether f is an increasing function, a decreasing function, or neither. So now fx is x degree 5 minus 10x cubed plus 50x. Okay, so now f prime x, it will be 5x degree 4 minus 30x plus 50. So to decide whether it's increasing, decreasing, or neither, that means we have to find the f prime x. Okay, so we have found the f prime x, then now we have to conclude, or we have to decide whether it is greater than 0 to get increasing function, or less than 0 for the first derivative to get the decreasing function. Okay, so from here, you can just compare. This is 5y squared minus 30y plus 50. Then this is 5x degree 4 plus 30x squared. Okay, missing. The square is missing. 30x squared plus 50. So when you compare these two expressions, basically the y is x squared. Right. So when y equals to x squared means that I will just direct refer to the previous part and change y to x squared. So I will be getting 5. Then the y over here will be changed to x squared. Okay, for the next part. So I will be getting x squared minus 3. Then another squared, and then plus 5. Alright, so from here, since your x is real number, so I know that for x is real number, x squared minus 3 and square it, it will be at least 0. Alright, so then 5 times x squared minus 3 squared, it will be at least 0 as well, because when you multiply by 5, then it will be same as you multiply the 0 by 5, so minimum is 0. Okay, therefore 5 times the term and plus 5, that means it becomes at least 5. Okay, so when it is at least 5, that means your f prime x is greater than 0. So therefore, or hence, fx is an increasing function. Okay, so that's all for this solution. Okay, now next question, question number 4. The first term of an arithmetic progression is 84, and the common difference is minus 3. A, find the smallest value of n for which nth term is negative. So now arithmetic progression, first term is 84, common difference is minus 3. So now nth term is negative, Tn is less than 0. So the formula is a plus n minus 1 d is less than 0. Then now replace the a and d values. So 84 plus n minus 1 multiply with negative 3, so it's less than 0. That means from here I will be getting 84. So this minus 3 times into the bracket, then I will be getting minus 3n plus 3 less than 0. Which means now left side is 87. This minus 3n will be moved to right side. It will be less than positive 3n. Hence, my n will be greater than 87 divided by 3. That means my n is greater than 29. So since your n is greater than 29, now we need to get the smallest n, which means it will be 30. Okay, so the smallest n is 30. Okay, so done for the A. Now B is given that the sum of the first two k terms of this progression is equal to the sum of the first k terms. Find the value of k. So S2k equals to Sk. So S2k is basically, okay, our formula. Sn equals to n over 2 times 2a plus n minus 1d. So now the n will be replaced by 2k and also k. Therefore, this will be 2k over 2 bracket 2a. Now, our a is 84. Okay, a is 84, d is minus 3. So, 2a plus n minus 1, d is minus 3. Then it's same as sk. So, k over 2, 2 times 84 plus n minus 1 times minus 3. Okay, so from here, basically, we can simplify the terms first. K over 2, this is k over 2. Alright, so now we just do expansion. So then you will be getting 2 times 2 is 4. So just do the expansion here. 4 times 84, it will be 336. Okay, then this is minus 3n. So minus 3n times the 2 outside, it will be minus 6n. Sorry, there's no n. It should be k, okay? Because sk. So this is 2k minus 1. Right, so here is 2k. Because now our n has been changed to 2k. And then same goes to this expression. It will be k. So now when you do expansion, minus 3 times 2k, it will be minus 6k. So minus 6k together with the 2 outside, it will be minus 12k. And same goes to the next one. Minus 3 times minus 1 is 3. 3 times 2 will be 6. So plus 6. Okay, so for the right hand side, again, we do the expansion. 2 times 84. And then this times, alright, then you will be getting 168 minus 3k plus 3. So now the k will be moved to right side. So I will get minus 3k plus 12k. And then for the left hand side, it will be 336 plus 6 minus 168 and minus 3. Okay, which means I'm moving these two terms to the left hand side. Then now, the total of the left hand side, it will be 171. For the right hand side, it will be 9k. So at last, your k is 171 over 9. Then you'll be getting 19. So that's the k value. Okay, next question, number 5. In the diagram, x and y are points on AB such that BX is 9. So BX is 9 and AY is 11. Okay, so that's the AY, 11. Arc BC is part of a circle with center X and radius 9. So BC, this is the arc BC. Okay, center X and radius 9, which means here is 9. So CX is 9, and then BX is also 9, because the X is a center. Now, where CX is perpendicular to AB, arc AC is the part of circle with center Y and radius 11. Okay, so arc AC, this is the AC. Center Y, okay, this is the center Y. And the radius is 11, so which means X, where is this? Okay, which means the YC is 11 and the YA is also 11. Okay, so now A, show that the angle XYC is this radians, correct to 4 significant figures. So to get XYC, so XYC means this angle. So to get this angle, we need to use the triangle XYC. Okay, so now CXY, and then from the labeling, I know that YC is 11, XC is 9. And this is the angle. Okay, and here is 90 degrees, right angle triangle. Therefore, I will just use opposite side, which is 9, and then the 11 is a hypotenuse. So sine angle XYC equals to 9 over 11. Therefore, the angle XYC is inverse sine 9 over 11. Then remember to change the mode of the calculator to radians. You will be getting 0.9582 radians. Okay, so that's the angle XYC. Now B, find the perimeter ABC. So ABC, okay, basically ABC consists of arc BC, which is this blue color, and then the arc AC plus BA. Okay, so first of all, I need to know what is the arc BC. So arc BC is a blue color. That means that is a sector with the center X and the radius 9. Okay, therefore I will just use the formula of arc length, which is S equals to R theta. Okay, S equals to theta R or R theta. So from here I will write arc BC, arc length of sector BC is theta R. So the theta R here is 90 degrees and the R is 9. Okay, so pi over 2 times 9. So that is 9 over 2 pi. That is my BC. So then when you refer to the AC, AC is the sector. Okay, it's the arc length of the sector AYC. the angle. Okay, just now we need the angle. We have found this angle XYZ. That means it's the angle XYZ times with the 11. Okay, that is our theta R for the arc length of AC. So you will be getting this value for the arc length of AC. So which means the blue line, the blue sector and the green sector already found. Then I need to find BA, okay, which is here. I need to find what is BA. So to get the BA, I need to know what is my XY first, because I know that BX is 9, but then XY I do not know. But then this XY can be found using the rectangle, the triangle XYC. Okay, because this is right angle triangle. So basically the XY value can be found using Pythagoras theorem, because we know the hypotenuse and we know the side here. Okay, so I will find the XY first, which means now the XY is square root of 11 squared minus 9 squared. Okay, which is, maybe I just write down the value first, YC squared minus XC squared. So YC squared minus XC squared, which is square root of 11 squared minus 9 squared, then it will be 2 square root 10. Okay, so found the XY, 2 square root 10. Here is 2 square root 10. Then now I can find the BY. What is this? So the BY is basically 9 minus 2 square root 10. Okay, so 9 minus XY. So that's my BY. So BY equals 9 minus XY. That means this is 9 minus 2 square root 10. Okay, then now my AB. Alright, so my AB is 11 centimeter plus the BY. Okay, so my AB is AY plus BY, which is 11 plus 9 minus 2 square root 10. Then you will be getting 20 minus 2 square root 10. So at last, the perimeter of ABC, it will be BC plus AC plus AB. Then you will be getting 9 over 2 pi plus 10.5402 plus 20 minus 2 square root 10. Okay, then from here, when you calculate the value, it will be 38.35. Then round up to 3 significant figures, it will be 38.4 centimeter. So that's the perimeter of ABC. Okay, for question number 6, given the diagram, the graph, okay, the diagram shows the graph y equals to fx. A on this diagram sketch the graph of y equals to f inverse. Okay, so for graph inverse, we need to draw the line y equals to x. This is the rough work. So f inverse is basically the reflection of the graph under the line y equals to x. So from here, when I draw the reflection graph, when you flip this part, okay, when you assume this is object, so the image will be over here, right? And then for this lower graph, when you assume y equals to x is the mirror, that means this object will be reflected to this. Okay, which means this will be my inverse graph. So this is my y equals to f inverse. Okay. Now, it's given that fx equals to negative x over square root of 4 minus x squared, where x is between minus 2 and 2. Find the expression for f inverse. So to get the f inverse, we just let the y equals to fx. That means your y equals to negative x over square root of 4 minus x squared. And then now we need to get the x as a subject. So this square root move up. So y square root 4 minus x squared is negative x. And then after that, to eliminate the square root, we need to take square both sides. Okay, so when I square both sides, then y squared, and then the square and square root cancel off, then I will get 4 minus x squared. Right hand side, it will be just x squared. Then now, just do expansion. For the left hand side, you'll be getting 4y squared minus x squared y squared equals to right hand side is x squared. And then now I need to group the x squared, okay? So which means this negative x squared y squared will be moved to right side. Then I will be getting 4y squared equals to x squared plus x squared y squared. And then for the right hand side, I will factorize the x squared. Then you will get 1 plus y squared on the right side. And now my x squared will be 4y over 1 plus y squared. And hence now your x will be plus minus square root of 4y over 1 plus y squared. Okay, then now I will change the x into f inverse. And then the y will be changed to the x. And then now to decide whether it's plus or minus sign. Okay, so now we have to check when you look at this domain, so we know that the range of f inverse equals to domain f. Okay, so in order to get this domain, I have to put a negative value. Okay, because of this formula, range f inverse is domain f. That this is our domain f, and this whole expression for f inverse will be the range. Alright, and then now we can simplify this. Okay, let me check, do I miss out any term? Okay, now when you see properly, this is 4y squared. Here you have squared. Alright, my square is missing. Then now when I simplify, I can just apply another formula, which is square root of a over b is same as square root a over square root b. That is going to be negative 2x over square root of 1 plus x squared. So this is my f inverse. Okay, so done for the f inverse for this question B. Now, the function g is defined by fx, gx equals to 2x, whereby the x is defined from minus a to a, where a is a constant. State the maximum possible a for which fg can be formed. Fg is a composite function. Just for information, to get fg, okay, this is fg. That means we need to solve the g first, right? So means that here start with g, then only f, which means from here I know that this is going to be domain f and also range g at the same time. Okay, this is range g because we have gone through the g function. At the same time, this is also domain f. So for fg to be axis, right? So fg to be axis or fg to be defined, the range g will be same as domain f. So now let's look at the domain f now. So the domain f is minus 2 to 2. Okay, so that's our domain f. So domain f is minus 2 to 2. Then the range G, okay, so range G is going to be 2x. Alright, so when you substitute this, so the range G is going to be gx between negative 2a and 2a. So you substitute the x into by a and also minus a. So obviously from here, okay, we know that when you equate them, alright, or maybe you can just refer to the upper limit. So therefore from here, 2 equals to 2a, hence maximum a is going to be 1. So that's the maximum a. Okay, that's all for this question. Now D, assuming fg can be formed, find and simplify an expression for fgx. So now fgx is same as f2x. So now our fx is going to be minus x over square root of 4 minus x squared. So which means now your x has been changed to 2x because of f2x. Right, so change this 2x to change this x to into 2x. So I will be getting negative 2x over square root 4 minus 2x squared. And then this is going to be negative 2x over square root of 4 minus 4x squared. And from the denominator, the 4 can be factorized out. So I will be getting square root of 4 brackets 1 minus x squared. And now we have a formula, which is square root AB equals to square root A times square root B. Okay, so which means from here I will be getting negative 2x over 2 square root 1 minus x squared. So the 2 will be cancelled off from numerator and denominator. At last, you will be getting negative x over square root of 1 minus x squared. So that is our fg. Okay, so done for this fgx. Now for question number 7. A, show that the equation can be expressed in this form. So first of all, I will rewrite the question. Then from here, the denominator will be moved up. But then when you refer to the given form, it will be in terms of sine. So it means that the tangent x will be changed to sine x over cos x. Alright, so from here, we need to get the same denominator, which is cos square x. Then I will be getting sine x plus cos square x equals to k bracket over cos x. Oh, sorry, it will be cos x because the denominator is cos x degree 1. Then first term will be sine x. Second term, if you make it to over cos x, it will be cos square x. Then from here, since we get the same denominator from both sides, then I will just ignore it. And then I will just do the expansion. Okay, so at the same time, when you look at the answer here, we just need sine square x and sine x, no cos square x, which means now we need to apply one more theorem or one more identity, which is sine square x plus cos square x is 1. And I need to get the cos square x as the subject. Then it will be 1 minus sine square x, which means I will be getting sine x plus 1 minus sine x, sine square x, which is our cos square x there, equals to k bracket sine x minus the cos square x will be 1 minus sine square x. Okay, Then now when you open the bracket, sine x plus 1 minus sine square x, right hand side will be k sine x, then this k times it will be negative k, then plus k sine square x. Then from the question, we need to group the sine square x and the sine x together. So which means, okay, and at the same time, it will be k plus 1 times sine square x, which means I will move all the terms from the left side to right side because I have the k sine square x on the right hand side. So all these terms move to right side and rearrange. So I will be getting k sine x minus k plus k sine square x, then minus sine x minus 1 plus sine square x equals to 0. Okay, then from here, my k sine square x and the sine square x will be first term. So it will be k sine square x plus sine square x as first term. And then by looking at the answer, k minus 1 times sine x. So I will rearrange first. That means my next term is going to be k sine x and minus sine x. Okay, and then here I have minus of k plus 1. So lastly, this minus k and minus 1, you factorize the minus. So I will factorize the minus, it will be k plus 1. Then equals to 0. Okay, so for the first term, you factorize the sine square x. I will write here sine square x. Then first term, it will be k. Okay, after you have factorized the sine x from second term, you still have plus 1. Here is the 1. The coefficient is 1. So then here, plus 1. Alright. Then I factorize the sine x. So plus, here is going to be sine x. Then left k and minus. So k minus 1. Then minus k plus 1 equals to 0. So with this, we have proven. Okay, we have proven the given form. Okay, next, hence solve this division equals to 4. So just now we have solved the division equals to k. That means now the k is 4. Okay, so k is 4, which means after I replace the k by 4 here, first term is 5. Then here is 3. Okay, this is 5. So I will be getting 5 sine squared x plus 3 sine x minus 5 equals to 0. Then from here, we need to solve, means that we need to find the x values for the x that define from 0 to 360 degrees. So which means this quadratic cannot be factorized. Now we have to apply the quadratic formula, which is ax squared plus bx plus c equals to 0. Then your x is going to be minus b plus minus square root of b squared minus 4ac over 2a. Okay, then from here, I will be getting a is 5, b is 3, c is minus 5. So sine x will be minus 3 plus minus square root of b squared. So 3 squared minus 4, a is 5, c is minus 5. Then over 2a. Then from here, I will be getting minus 3 plus minus square root of 109, then divided by 10. So final answer will be 0.7440. And another one is negative 1.3440. Okay, so we know that sine graph. So for the sine graph, maximum is 1, minimum is minus 1. So this value is exceeding the interval, therefore this is omitted. So I will just accept sine x equals to 0.7440. Okay, now let me count this first. Hang on, please. Okay. So when sine x equals to positive value, right, it will be in first two quadrants. So I will be getting first two quadrants means here. So when you use your calculator to get the basic angle, it will be 48.1 degrees. Same goes to the second angle. Okay, second quadrant. That means now my x is going to be 48.1 degrees, and then the next one is going to be 180 minus 48.1 degrees. Then it will be 48.1 degrees and 131.9 degrees. So that's the solution of this question. Okay, so next question, number 8. The diagram shows the curves with equations y equals to x to the power negative half and y equals to 5 over 2 minus x degree half. The curves intersect at the points A and B. So these are the 2 points. Find the area of the region between the 2 curves. So area between the 2 curves is basically this region. Okay, so obviously the region is towards the x-axis, therefore we need to use integrate y dx, and it is from 1 over 4, which is from the x coordinate of A until 4. Okay, that's the bounded region. So now my A area equals to integrate from 1 over 4 to 4. So then we always refer to the upper graph. So when you look at the graph here from 1 over 4 to 4, just pick a point here. This is the upper graph. Upper graph is upper graph is this. This is the upper graph, and then you minus the lower graph. Lower graph is y equals to x power negative half. So means that my calculation here should be 5 over 2 minus x to the power half, then minus x to the power negative half. Alright. So then I will just direct integrate. So when you integrate, always plus 1 to the degree of x. Right. So that means 5 over 2 becomes 5 over 2x. Then x power half, it will be x to the power of 3 over 2, because half plus 1 is 3 over 2. Then you divide by 3 over 2. That means I can just write times 2 over 3. Then minus x minus half plus 1, it will be half. So you divide by half is same as you times 2. Okay, or probably I just show you step by step, then you can see clearly. So here is going to be negative over 3 over 2. Then this is minus over half. Then limits from 1 over 4 to 4. Then from here I will simplify 5 over 2x minus 2 over 3 x to the power of 3 over 2. Then minus 2x power half. Limits from 1 over 4 to 4. Then now when you simplify, it will be 5 over 2 times 4 minus 2 over 3 times 4 to the power of 3 over 2 minus 2 square root 4. Okay, these are the terms when the x is replaced by 4, and now the x will be replaced by 1 over 4. So I will get 5 over 2 times 1 over 4 minus 2 over 3 times 1 over 4 to the power of 3 over 2 minus 2 square root of 1 over 4. Okay, then from here, you will be getting 2 over 3, then minus negative 11 over 24. So at last, you will be getting 9 over 8. So that's the solution of this area bounded by the two graphs. Okay, next, B. The normal to the graph y equals to x to the power negative half at the point 1, 1 intersects the y-axis at the point 0, p. Find the p. So first of all, we need to find what is a normal. Before we get the equation of normal, we need to get the gradients of normal. And before we get the gradients of normal, it's compulsory to get the gradients of tangent, which is the dy dx. Okay, gradient of tangent. Gradient m tangent, I will write m tangent equals to dy dx. Okay, which means now I need to differentiate. So my y is x to the power of negative half. So dy dx. Bring down the negative because we are using this formula d over dx x degree n. So it will be nx n minus 1. So then from here, I will get minus half x to the power of negative 3 over 2. Then at 1, 1, right? So at 1, 1, my dy dx is negative half times 1, which is negative half. Then now, my gradients of normal equals to negative 1 over dy dx. Okay, because the dy dx is gradient of tangent. So it means that you'll be getting negative of 1 over negative half, which is 2. So from here, since you need to find, or you were given that the normal at the points 1, 1 intersects the y-axis at this point, means that now we need to form the normal equation first. What is a normal line equation? So now equation of normal at 1, 1. So the formula is y minus y1 equals to m bracket x minus x1. So now I will be getting y minus y1 is 1, then the m is 2. So x minus 1. Therefore, y equals to 2x minus 2 plus 1. Hence, you will be getting y equals to 2x minus 1. Okay, and then given the point, okay, intersect at the y-axis, that means your x equals to 0. So at x equals to 0, y equals to p. That means now p equals to 2 bracket 0 minus 1. So I will be getting p equals to minus 1. So that's the solution of this question. Now question number 9. The line intersects the circle with equation x squared plus y squared equals to 20 at the points A and B. So now A, find the coordinates of AB in third form, and hence find the exact length of the chord AB. So since they are intersecting, means that we have to solve the simultaneous equations. So y equals to 2x plus 5 as the first equation, x squared plus y squared equals to 20 as the second equation. So now I will substitute first into second, which means x squared plus 2x plus 5, which is my y, then you square it, equals to 20. And I'll do the expansion. For the second term, to expand the squared, we are using this quadratic expansion. Okay, then you will be getting x squared. Now the square of 2x will be 4x squared. So 5 times 2x, which is our a and b, then you have to times another 2, which is 20x. Then plus 5 squared is 25, equals to 20. So x squared plus 4x squared will be 5x squared. Then the third term, plus 20x. This 20 move to the left side becomes plus 5 equals to 0. Okay, this quadratic equation can be solved using quadratic formula. Okay, but before that, I will divide the whole equation by 5 first. So here becomes x squared plus 4x plus 1 equals to 0. So I have introduced the quadratic formula just now. Write down the a, b, c and substitute into the quadratic formula to get the x. So my x will be minus b is my 4, plus minus square root of b squared, which is 4 squared, minus 4 times 1 times 1. This is my b squared minus 4ac, then divided by 2a. So from here, you will be getting minus 4 plus minus square root of 12 over 2. So then, because the question says you have to find the coordinates of AB in third form, so it means that my x must be in exact value. Okay, so then my x here, I will further simplify it into minus 4 plus minus this 12. Okay, square root 12, it will be same as square root of 3 times 4. So use the formula, it will be square root 3 times square root 4. So square root 4 is 2, therefore 2 square root 3. Okay, then I will be getting 2 square root 3, then over 2. So at last, it will be negative 2 plus minus square root 3. I get 2x. So one of them is A, another one is for B. So now with this x, then we have to find the y by substituting it into first equation. So from here, I will just write when x equals to negative 2 minus square root 3, right, from 1. My y is 2x plus 5. That means I will be getting 2 times negative 2 minus square root 3 plus 5. Then you will be getting, the first one is minus 4. So minus 4 plus 5 is 1 minus square root 3. That is my first y. Okay, wait, let me do it step by step. So here, okay, the 2 multiplied to the whole bracket. Just now I overlook it. So that means here is going to be minus 4 minus 2 square root 3 plus 5. So it's going to be 1 minus 2 square root 3. Okay, now when x equals to minus 2 plus square root 3, your y is going to be 2x. Then plus 5. So again, now you do expansion. Then you will be getting minus 4 plus 2 square root 3 plus 5. That means it is going to be 1 plus 2 square root 3. Okay, so from here, I will say my a will be negative 2 minus square root 3, comma, my y is 1 minus 2 square root 3, and then my b will be minus 2 plus square root 3, and then my y coordinates will be 1 plus 2 square root 3. Okay, so done for A and B. But then hence, find the exact length of AB. So now we need to find length. So AB, we have one formula here. Square root, okay, let's say A is x1, y1, and then B is x2, y2. Then the AB is going to be square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, that is the arc length formula. So that means now I will be getting square root of minus 2 plus square root 3, then plus, right, because here is minus, right, or probably I just write minus. So minus negative 2 minus square root 3, then squared. That means this is my x1, this is my x2, plus 1 plus 2 square root 3 minus 1 minus 2 square root 3 squared. Then from here, it's going to be, okay, minus 2 plus square root 3. Bring in the minus. So it becomes plus for both. So plus 2 plus square root 3. Then square it plus. And again, this minus will be brought into the brackets. Then you will be getting 1 plus 2 square root 3. So minus 1 plus 2 square root 3. Okay, so minus 2 plus 2 will be 0. Then I will get 2 square root 3. Plus, so the 1 and minus 1 cancel off. I will get 4 square root 3. So at last, it will be 4 times 3 plus 16 times 3. And then there is a square root. So you'll be getting 12 plus 48 with the square root. Then at last, it will be square root of 60. So square root 60, we know that it is going to be 4 times 15. Okay, then at last it will be 2 square root 15. So this is your exact length of AB. Now, part B. A straight line through the point 10, 0 with gradients m is the tangent to the circle. Find the two possible values of m. So now, since it's mentioned it is a tangent, right? So tangent of circle, tangent at 10, 0 with m, with gradient m. So I will write y minus y1 equals to m bracket x minus x1. So at last here will be y minus 0 equals to m bracket x minus 10. So at last it will be y equals to mx minus 10m. This is my first equation. Okay, the straight line. And then it is tangent to the circle. So now I will copy back the circle equation, which is x squared plus y squared equals to 20. So I let this be second equation. Now I substitute first into second, right? Because when it is a tangent means that there will be one intersection point. So again, I'm solving simultaneous equations. So now x squared plus mx minus 10m squared equals to 20. Then when you do expansion, first term remains, second bracket mean the square of mx minus 10. When you do expansion, it will be m squared x squared minus 20 m squared x plus 100 m squared. Then the 20 will be moved to left hand side. Left hand side, it becomes minus 20. Okay, then from here, I will factorize the x. I will group the terms with the x squared. Okay, so it will be x squared bracket 1 plus m squared, and then the term with the x will be just plus x bracket minus 20m squared, and then the constant is going to be 100 m squared minus 20, that equals to 0. And now, to get tangent, we know that there will be just one intersection point. Okay, tangent means b squared minus 4ac equals to 0. So before that, I will just write down my a is going to be 1 plus m squared in the quadratic equation, b equals to negative 20m squared, and then c equals to 100 m squared minus 20. So now tangent 1 is a tangent. Okay, the first equation is a tangent. Tangent means b squared minus 4ac equals to 0. Only one solution. So now replace the ABC. It will be negative 20m squared. This is our b. Squared it. Minus 4. A is 1 plus m squared. C is 100 m squared minus 20. Then equals to 0. Now, from here, when you do expansion again, it will be 400 m squared minus this 4 I times in, so write a minus outside. 4 plus 4m squared multiply with 100m squared minus 20. Okay, and now further simplify or further expansion. So I will be getting 400. Okay, so this is a mistake. This is degree 4. Because here is squared. Square of square will be degree 4. Minus. Okay, so do expansion for these 4 terms. You will be getting 400 m squared minus 80 plus 400 m degree 4 minus 80 m squared. That equals to 0. And now open all the brackets. It will be 400 m degree 4. Okay, this 400 m squared minus 80 m squared, it will be 320 m squared. But there is a negative in front. So it becomes negative 320 m squared. Okay, then the minus, right? This one you times in. So instead of minus 80, now it becomes plus 80. Then minus 400 m degree 4 equals to 0. So the 400 m degree 4 will be cancelled off. Then this m squared, the term with the m squared will be moved to right side. It will be 320 m squared equals to 80. Therefore your m squared is 80 over 320. Then that will be 1 over 4. And at last, your m is going to be plus minus 1 over 2. Okay, because you take the square root. So when you look at the question, 2 possible values of m. So we have found the 2m values here, which are 1 over 2 and negative 1 over 2. Okay, next question. Question 10. A curve has equation y equals to fx and is given f prime x. The curve has minimum point at x equals to 2. So when you see minimum points, means that it will be f prime x equals to 0. Okay, which is a stationary point. Now, find f double prime x in terms of k and x, and hence find the set of possible values of k. So I will rewrite my f prime x. So my f double prime x, I bring down the negative 2, rewrite the whole bracket, then the degree you minus another 1, means that becomes minus 3. Then differentiate half x, it will be half. Okay, then this negative 2 degree move down, becomes plus 2. So I will get plus 2 bracket 1 plus k. The degree, the existing degree is minus 2. So now you minus another 1, becomes minus 3. Okay, wait, there's a mistake. This term without x, therefore when you differentiate it will be 0. Okay, so I shouldn't have any terms there where I differentiate. So I should get just this differentiation. Alright, then now I simplify. So the 2.5 cancel off. Then you will be getting negative of half x plus k to the power of negative 3. So then now it's mentioned that okay, so we have done this part, the first part done already. And then now hence find the k values. Okay, so we know that minimum points at x equals to 2. So which means at x equals to 2, the f double prime x is greater than 0. That's why it's minimum. Okay, so then I will just write negative of half x plus k to the power of negative 3 is greater than 0. So then the x will be replaced by 2. Okay, so I will replace here directly. Then I will be getting negative 1 plus k to the power of negative 3 is greater than 0. So when you see negative degree, which is the negative 3, I will move it down. So negative 1 over 1 plus k to the power of 3 is greater than 0. Then now the negative move to the other side, then you have to, I would say, this move up. Okay, then negative of this is greater than 0. Okay, that means okay, it is greater than 0. Then your k is going to be negative, right? Because if here is already negative, or I will say like that. Now, because this is negative, I don't move up first. I times the whole equation by negative. Right? I times the whole equation by negative. So times by negative 1. So when you times by negative 1 is 1 over 1 plus k. Then degree 3 is less than 0. Okay, so in order to get less than 0, so since my numerator is 1, which is positive, that means my denominator must be less than 0. Okay, so that it will be the whole value will be less than 0. So 1 plus k to the power of 3 must be less than 0, must be a negative value. So therefore, 1 plus k will be less than 0. You move the 3, the cube to the other side becomes 1 over a cube root. Okay, cube root of 0 is 0. That means my k is going to be less than minus 1. So that is my k value. Okay, now is now given that k equals to minus 3. Okay, that's why k less than minus 1. And the minimum point is at 2, 3.5. Find fx. So to get fx, we need to rewrite our f prime x. So f prime x, half x plus k. Replace the k first. The k is minus 3. So half x minus 3 to the power of negative 2. Then after that, minus 1 plus k to the power of negative 2. So the k is minus 3. Then here is going to be half x minus 3 to the power of negative 2. Then minus 1 minus 3 is minus 2. Minus 2 to the power of negative 2, it becomes 1 over 4. Okay, so with this, to get the fx, we need to integrate. So fx is the integration of half x minus 3 to the power of negative 2, then minus 1 over 4 dx. So then, when we integrate, we plus 1 to the degree. So I'm using this formula, ax plus b to the power of n dx is going to be ax plus b to the power of n plus 1 over the new degree, and differential ax plus b is a together with the plus c. Therefore, now I will be getting half x minus 3, degree minus 2, you plus 1 becomes minus 1, over minus 1, and differential half x minus 3 is half. Okay, that is our differentiation. And then the minus 1 over 4 becomes minus 1 over 4x, and don't forget to write the plus c. So now, when you see the denominator is negative half, so 1 over negative half is negative 2. And then the numerator with degree of minus 1. So this whole term will move down. That means it becomes fx equals to negative 2 over half x minus 3. Then minus 1 over 4x plus c. Okay, and then it's mentioned that the minimum point is at 2 and 3 over 2. Right? So then, but then we seldom leave our answer as half x minus 3, the fraction in the denominator. So what to do is I will simplify first before I replace the coordinates. So I will write over 2, make it to over 2 first. So it will be x minus 6. Right? You make it to denominator of 2 for the 3 there. So here minus 1 over 4x plus c. So then use the formula A divided by B over C. This is A over 1. That means it's A over 1 times C over B, which is AC over B. So the C here will be moved up. That means this 2 will be moved up. Okay, then I will be getting minus 4 over x minus 6. Then minus 1 over 4x plus C. Then this is my fx. But then of course to find the C, you need to replace the point. So x is 2, y is 3.5. So x is 2, fx is 3.5. That means this is same as 7 over 2. So at last, 7 over 2 equals to negative 4 over 2 minus 6 plus 1 over 4 times 2 plus c. So then I will get 7 over 2 equals to, this is going to be 1, then plus half plus c. Okay, this is minus 1 over 4, so here it's going to be minus. It's not a plus. So at last your c is 3. So from here, my fx is going to be minus 4 over x minus 6 minus 1 over 4x plus 3. So that's the fx. Okay, part C, find the coordinates of other stationary points and determine its nature. So now, to get stationary points, let f prime x be 0. So now our f prime x is half x minus 3 to the power of negative 2 minus 1 over 4. So let this be 0. So first of all, the 1 over 4, negative 1 over 4 will be moved to right side. At the same time, the power negative 2 I will move down. Okay, so it means that I will write 1 over. So when you compare, okay, the denominator will be equal. So half x minus 3 to the power of 2 equals to 4. Then to get the x, because we need to get the coordinates of the stationary points, means we need to find another x for which the f prime x equals to 0. So now the square will be moved to right side, becomes plus minus square root 4. Okay. Which means I will be getting half x minus 3 equals to 2, or half x minus 3 equals to negative 2. So then the first one, half x is going to be 5. So the x is 10. Then the next one, half x equals to 1. So the x is 2. Okay, so now we have, you were given just now the point at x equals to 2. So that means the other stationary points will be when x equals to 10. So now I need to find what is my y value, okay? So x equals to 10. So now my fx, my y value is fx. It will be negative 4 over x minus 6. Then minus 1 over 4x plus 3. So here is going to be minus 1. Then minus 5 over 2 plus 3. Then it will be negative half. So other stationary point equals to 10 and negative half. Okay, and then to determine the nature, we need to refer to f double prime. Just copy back from the previous solution. So the f double prime we have solved just now in the part A, which is negative of half x plus k to the power of negative 3. And the k is minus 3. Okay, so negative half x. So I will rewrite negative half x minus 3 to the power of negative 3. So at x equals to 10, f double prime x is negative half times 10 minus 3 to the power of negative 3. So here is going to be negative 1 over 8 and it's less than 0. Then we will conclude that the point with coordinates 10 and negative half, it is a maximum point. Okay, so right, we have solved this question and also we have come to the end of the video. Thank you for watching. Please subscribe to the channel if you enjoy watching my video and recommend it to your friends. Not to forget to stay tuned for more upcoming videos as well. Thank you. Bye.